So I'm going to talk about how we can predict mental illnesses by looking at your Twitter feed. This work is done by myself, Kadiel Morales, and my advisor, Rachel Greenstadt. Being able to identify mental illnesses and suicide ideation can be very helpful. Social media platforms have thought about this over the past couple of years and have deployed, for example, suicide prevention tools. Technology can play a big role in identifying mental illnesses. On the other hand, unfortunately, there's a lot of stigma associated with mental illnesses. For example, people could be excluded from social circles or discriminated in their workplaces. So therefore, most people would like to keep their mental health status private. Some of the past research in psychology have shown that individuals who have mental illnesses have deviations from normal language use. For example, people who have depression tend to use more personal pronouns. So these studies in psychology are based on patient essays and interview transcripts and tend to be more small-scale studies. But more recently, people have used machine learning on social media text and online forum and have shown that mental illnesses can be predicted using machine learning. So this raises numerous privacy concerns, and I'm very thankful for the PET's keynote speaker because he covered a lot about social media target audiences and data brokers. So, for example, could someone create a list of people who potentially have a mental illness and target advertisements towards them? Or could a data broker collect the mental health status as part of the profiles they build on people? Or could an employer screen the social media post of a potential employee and assess their mental health status? While there are policies to prevent such usages, there are no real technical solutions. So, in order to understand the privacy concerns, we first need to understand the machine learning model and see what it's learning. So, in the rest of my talk, I will talk about the dataset and the machine learning model that we use. And then we did a feature analysis, which actually served two purposes. One is to identify the machine learning model, and secondly, to discover language patterns. And in our analysis, we were able to identify some of the already known language patterns, and we were able to see some new patterns as well. We will also analyze where this machine learning model fails, and this will help us understand the model better. So the dataset that we used is a widely used dataset in this domain. It's used at a workshop where researchers build classifiers to predict if people have depression or PTSD by looking at their Twitter feed. So one of the problems of creating a larger scale dataset is that it is very hard to create gold standard ground truth information like clinical screenings. So the way that this particular dataset was created is if somebody said that they were diagnosed with depression or PTSD, their most recent tweets, except the diagnosis tweet, is collected into the dataset. And to form a control group for each user in the positive class, a random user with the same age and gender is assigned as a control pair. Now, there are some caveats about this dataset that I don't have a lot of time to go into, but some of the studies that have been done on this dataset shows that it is consistent with some of the already known language patterns that are based on clinical studies. And if you looked at the results from that workshop, the classifiers seem to be fairly accurate, and they have used models like bag of words, character engrams, and topic modeling systems. So when we got this dataset, one of the first questions we had was, since these people did declare their mental illness on Twitter, maybe they are talking about it on other tweets as well. And this actually turned out to be true. There was a good fraction of instances where people did talk about their mental illness, and some of our earlier feature analysis showed that words like diagnosed, depression, PTSD were some of the features with a high information gain. So if these people are actively talking about their mental illness, and this is what the machine learning models are learning, the privacy implications are not very high. So we wanted to measure the effect that these direct mentions would have towards the prediction accuracy. So to To do this, we filtered out the tweets that talk about mental health. So we took a sample of tweets, labeled these tweets as to saying, indicating if they talk about depression, PTSD, general mental health, or a regular tweet. And then we trained a classifier on that, and then that was used to label the rest of the tweets, and all the tweets about depression, PTSD, and general mental health was removed from the data set. And what we thought we would see was a significant drop in the performance. But we didn't actually see such a big drop. So what this sort of indicates is that even if people are not talking about their mental illness, there are enough signals in the language to make fairly accurate predictions. Now, let's put these numbers into perspective. Some of the research done in this area shows that both our results and similar classifiers, the performance of them falls somewhere in between the performance of primary care physicians in diagnosing depression using clinical interviews and screening inventories, which are questionnaires that are specifically designed to diagnose depression. And going forward, we added two new feature sets to our model. We used a set of 1,000 pre-computed word clusters and treated all the words in the given word cluster as a single token. So this helped the model to generalize better to unseen words and handle the various ways that people use language on Twitter. And we also wanted to measure the grammatical level differences of people who have mental illnesses and those who don't. So we used a power of speech tagger, which identifies the power of speech of each word. For example, is it a noun, a verb, a preposition, and so on. We actually used two power of speech taggers. The first one is more geared towards well-formed sentences, so sometimes it doesn't work well with Twitter, but the advantage here is that it gives really fine-grained part of speech tag information. And the next part of speech tagger is more geared towards Twitter, but it doesn't give as fine-grained information as the earlier one. So we see two complementing views from these part of speech taggers. And in our experiments, we saw that a combination of all of these feature sets works the best. To analyze the features, we computed the information gain for each feature. We also used statistical approaches to identify features that have values that are significantly different between the two classes. And we also evaluated the size of this difference using Cohen's d measure. And if you look at the results, these are the results for the depression versus control task. And these are the content level features, which are bag of words and word clusters. The size of the words represent the information gain, and the color represents the Cohen's d, and words that are more shaded red are more frequent in the positive class, and words that are bluer are more frequent in the control class. So we see in depression this high frequency of profanity, words like I, myself, conjunctions like and because, and intensifiers like so much. And on the control side, we see a lot of social media abbreviations like LOL, SMH, hashtag sorry not sorry, and words that describe day-to-day life like homework, home, and days of the week. And if you look at the PTSD results, we see similar patterns, and some words describing self-focus, pain, and suffering, and some words that are related to military. And on the control side, we see more frequent words about routine activities, and again, days of the week. If we look at grammatical level differences, we see that for both tasks, coordinating conjunctions like and, but, because, or seem to play an important role. And for the depression versus control part, we see nouns used together with adjectives and adverbs. So usage examples include things like I'm pretty sure, I'm so excited, I'm so, to be more important. And for the PTSD versus control task, we see one of the most important features was personal pronouns used together with past tense and past participle verbs. So usage examples are like, I was told, I was gonna, I was, it was. So looking at this, we see that even though there are no direct mentions of depression, there are more signals in language that helps a classifier make good predictions. So what about the estimated performance of such a classifier on a general population? In a general population, the prior probability of having a mental illness is very low, and these classifiers are not super accurate. So if we did like a Bayesian detection rate calculation, we see that even if a classifier predicted if somebody is having depression or PTSD, the actual probability of them having it is quite low. But I want to revisit the clinical diagnosis scenario. So we believe that this probably works because the prior probability in a clinical setting is much higher than in the general population. But we wanted to look at these misclassifications to understand what they are. So to do this, we took a sample of misclassifications and tried to manually identify the most likely reason that why these instances was classified as why these instances were misclassified. So for some of the instances we couldn't find a reason, but for those who did, these were some of the reasons. So for depression, some of the reasons for false positives was a higher frequency of self-focused tweets complaining about difficulties in life, relationship, and this is one of the undesirable biases. Some of the people in the control group tweeted a lot about interests that was shared by people in the depressed group, like certain bands and music. I have bad news for One Direction fans. There's a question.
So it seems to me you don't have a depression group and a control group. You have a depression group and an unknown general population group, right?
So this was one of the caveats of the data set, and this is, I mean, in this setting it's really hard to sort of identify that. But one of the things that we did try was, so I guess where we want to go at is if we can do this in like this setting where it's very easy to collect data, perhaps this is a good motivation to do a study where we can collect better ground truth information. So this is one of the issues of the data set, that there's noise. But again, the prior probability of somebody having a mental health illness on the control set is quite low, but it is there. Okay, that's a
So the people that you put in the kind of depressed group are people who are openly talking about it.
Yeah.
So could it be that people who are openly talking about it, they talk about other things in a different way, or they touch on different topics than people who are actually hiding it?
Yeah. So that's one of the other issues as well. Again, what we saw, I mean, what some of the studies have done is like it shows the similar patterns to people in like clinical studies. And another experiment that I did, which is really small, so I cannot be like really conclusive about it, is that we looked at a small number of instances where people said, I was diagnosed with depression today, and then we looked at the tweets before that. So like those people didn't actually know they were diagnosed, but it's not very conclusive.
There are people who openly talk about this.
What?
Others might be trying to pretend they're happy, right? And then they might not.
Yeah, so there could be personality differences, yeah. But again, our idea is that this would motivate more research that would do on a proper clinical population. Yeah.
Ethics of this doesn't change the fact that it's sort of creepy to diagnose people over the internet. And so I really, first one to do this research, and so like, the main ethical bug or problem was the original authors of the paper that made this. But do you think that, the first faults of the original authors that clearly didn't think of that too much makes it sort of okay to do more analysis of this data? How do you approach these issues?
Could you repeat the question?
Yeah, so in short, there's really problematic ethical questions with the fact of diagnosing people over the internet. Even if the data is public, they probably did not expect this to be used this way, right? So I understand that you're not the first to do this research, to basically do the borderline unethical things. But my question is, do you think that the fact that people did this before you and generated that before you makes it okay to do further analysis of these data sets? So how do you approach these issues in general?
Maybe Rachel has some.
Yes. So this data set was both originally collected by Johns Hopkins, and they went through a procedure with their IRB and their ethics board to address the collection of it. It's not actually, even though the data is public and you could probably reproduce it, it's not actually a public data set. We also went through our IRB on what we were going to do with it, and did get the and then got the data from Johns Hopkins based on that. It was to some extent de-identified because it wasn't the account, there wasn't, so we couldn't do necessarily followers and stuff like that because it was just the data for these perhaps reasons. And I think the fact that again the data set was collected by people who had publicly declared their diagnosis mitigated some of the ethical concerns because this was clearly something that people had publicly announced on Twitter. But it also isn't a public data set that's just out there. For a clinical population like we've been talking about that would be helpful, we would obviously do a much more rigorous sort of ethical review with much more important, with informed consent of participants in that case. But, it's not perfect, but we did consider these things.
I would go through the next, I have 3 more slides and then open it up for questions. So if you look at the false negatives, interestingly, there were people who had depression that was diagnosed a long time ago, or either they were treated and under medication. And some of the other reasons for false negatives were content issues like having a lot of abbreviations, emojis, and non-English tweets. For PTSD, some of the false positives were people who had some military-like content or certain sports, and people who had a lot of tweets of expressions of anger and sadness. And for false negatives, some PTSD cases where it's non-military based, and people who tweeted more positive sentiments, and content issues like having a lot of emojis. So if you look at the conclusions, we see that machine learning models do identify mental ill users even if they were not directly talking about their diseases. And for machine learning in general, it is important to look at what your machine learning model is learning and do a feature analysis, because in our case we were able to learn more about language use and mental health, and we were able to see some of the previously known language patterns, and we were able to identify some new patterns as well, like the use of conjunctions, intensifiers like so much, and for PTSD, the use of personal pronoun, past tense, and past participle verbs. And there are some undesirable biases that the models learn, like our model was somewhat biased towards military-related PTSD issues. And on future works, we want to analyze the different applications, the feasibility of them, and the privacy implications. If there's more questions, I would like to take them up.
So we have 10 minutes for questions.
Okay. So thank you for the talk. So just a couple of questions about feature selection and data. I saw that, for example, you had stop words like "and" as very significant words in there. Did you try just removing all these stop words, including the days of the week, or were they just too significant?
So we actually didn't, function words were actually one of our features because previous literature shows that it was like these sorts of words, like personal pronouns, for example, which are usually removed in other NLP tasks that give out valuable information. So that's why we kept those features to see if there's a significant difference.
I see. A second but related question is about learning the style. You had one slide on that. I remember you kept learning the also structure of the sentences. But what about like more automated approaches? For example, in NLP now there's talk about learning the style and a style transfer of a particular passage to some other passage. So learning the style of a writer and trying to apply it to something else. But have you ever thought about learning the style of people who have PTSD or who have clinical depression?
Yeah, so based on literature, some of these feature sets are used in, for example, authorship attribution, like part of speech tag bigrams and things like that. But we didn't look at like the particular approach that you mentioned, but something that we could do in the future. Oh yeah.
It's okay. I can go whenever. First of all, thank you for setting up our next talk. I have actually a more technical question though about something you said earlier in the talk, which is about how you tagged the tweets that were specifically talking about depression. What was your accuracy for that model? Why didn't you use something more basic, like just looking for diagnosed, depressed, whatever, things like this? And how did you validate it?
So the accuracy for that, we had like really good recall, so we were like sure that most of the tweets that are related to depression and they were removed. Some of the false positives were things like depression related to weather. So we didn't really like focus on that. Yeah. And what was there like a second part? Yeah, it's hand labeled between two authors, and then we had a high inter-author agreeability.
Okay, so Carmela.
I'm sorry.
In the 60s, they developed the DSM checklist as a objective way to analyze whether somebody had a mental disorder or not, because they had seen how faulty and error-prone human diagnoses were of mental disorders, and but there's a minority group of people within the psychiatric community who is worried that actually what these feelings of mental disorders are actually normal human feelings of discontent that we're diagnosing as mental disorders. And it's very interesting because I'm seeing in your diagnosis through patterns of speech a very similar trajectory in the development of psychiatric diagnosis. And the question I'm wondering about is, by diagnosing the population of society, maybe there's a tendency when people are feeling weak or vulnerable to want to be diagnosed, to want to have some kind of disorder as a kind of sense of comfort that there is something wrong that can be fixed. And I'm just interested what your thoughts on that are. Is there some kind of danger of creating a feedback loop where we end up diagnosing society and also at the same time actually creating mental disorders where maybe before there wasn't a mental disorder?
Yeah, so I'm not like a medical professional, so I don't know how I could answer that. But what we want to do here is like to create awareness and to analyze like what would be the potential privacy implications. because we do see this as a serious problem, and what can be done about it, and that's some of the things that we want to study in the future.
Thanks. So Carmela had this question, but for some reason she wanted me to ask it. So
Goes better. Yeah.
okay. So with the tenfold cross validation you have here, was that you randomly took a tenth of the tweets out, or you randomly took a tenth of the people out? Like, did you ever train and test on the same people?
So this particular one where we labeled tweets to remove from the dataset, that was on individual tweets, but the cross-validate, like the results for, like the main results where we showed the accuracy of the main system in diagnosing depression and PTSD, that was based on user level, not individual tweet level.
So did you do, was there cross-validation on that?
Yeah, so these were cross-validated.
Okay, so
and these were results of individual users.
Trained on other people and then showed it people it had never seen before.
Yeah,
okay.
Yeah.
Good. Yes, I also have capital opinions on the question about like what is depression and what is mental illness, but I don't think now is the time.
So I have depression. It is pretty well treated these days, and I'm doing okay. If anyone wants to claim there is no such thing, or that it's a made-up illness, I would like to introduce them to a number of very intense engrams in my vocal patterns. But what I would like to hear is, how, if at all, is this work supposed to benefit me?
So we want to prevent, like we want to sort of identify the misuses of, since there have been studies on that this can be, machine learning can be used to do this, we want to know, okay, we want to understand the privacy implications, and we did the feature analysis to see why and how this happens. And going forward, we will be able to study like the deeper privacy impacts and probably suggest some methods to technically prevent this, rather than, like, for example, social media platforms have different policies to, for example, not have advertising. So that's something we want to look at.
So this is in some sense a follow-up to Nick's question. One of the real benefits of the internet has been the ability for small communities to sometimes communicate anonymously. For communities like... Sure. One of the real benefits of the internet has been the ability of small communities to communicate, and sometimes to communicate anonymously. It seems to me this kind of work has the potential for shutting them off, for telling them that they will be discovered as being depressed and labeled. And instead of having an outlet to communicate with people like themselves and share, we're doing exactly the wrong thing by doing this kind of work.
Yeah, so I want to mention, this kind of work had been done before, and so our idea was to see why they work, and by doing so, understand the privacy implications. And maybe Rachel wants
to follow up on that. Yeah, we looked at this study that had been done in Johns Hopkins, and we had exactly the same concerns that you did, and we said, well, maybe it's not. Our hypothesis is maybe this isn't a big deal. Maybe all it's doing is detecting the content, that it's and that was what we've and just detecting, okay, these people are talking about the things. That was what we actually expected to find. And then we ended up finding these sort of underlying patterns. I do think that there's sort of some perhaps benefit in the fact that we've discovered new linguistic patterns that may help clinical research, help clinical diagnosis and so on. But I do find it somewhat troubling, and it's not clear where we're going to necessarily go from here. But we came at it from the approach of saying, with that concern, saying, is this actually the problem that it seems to be, that, or is it just detecting the word depression or whatever? So And this was what we found.
There's one last question.
Yeah, hi. I'm just slightly worried that you're trying to classify something that isn't inherently that easily classifiable, and I wouldn't underrate domain-specific knowledge about this. The DSM has quite a controversial history, and I think these things really require a domain expert to collaborate with if you're not doing that already.
Yeah, so I mean, in our initial work, we did talk with some of the people who had done psychological studies, but definitely it'll be something that we could work on in the future. Yeah, thank you.
Okay, so that's the end of this talk. Let's thank the speaker again.
Okay, just a quick public service announcement for the people listening in.